this video we're going to go over Ka and buffer solution calculation. Just as a quick disclaimer, this question is from AQA past papers for A-level chemistry, so we'll be just doing this question, but it's good to see how you calculate buffers and how it involves in the acid dissociation constant. So buffer is a solution that resists a small change in pH. pH is a logarithmic scale of hydrogen ion concentration, and you calculate Ka using this formula. You calculate the acid dissociation constant like this. This is an example for ethanoic acid. So the value of ethanoic acid acid dissociation constant is 1.7410 to the negative 5 at 25 degrees. A buffer solution is prepared using ethanoic acid and sodium ethanoate. In the buffer solution, the concentration of ethanoic acid is 0.186 moles per decimeter cubed, and the concentration of sodium ethanoate is 0.105 moles per decimeter cubed. And it wants us to calculate the pH of the buffer solution to 2 decimal places. So first of all, we're going to write out the information that we're given. So we were told that the concentration of ethanoic acid is CHCO3 is 0.186. We were told the concentration of sodium ethanoate is 0.105. So we have this bit. 0.105. From this equation above, to calculate Ka, we're already told Ka though, so we need to calculate the hydrogen ion concentration. So if we rearrange this equation, we have Ka multiplied by the concentration of ethanoic acid divided by the concentration of sodium ethanoate gives you the hydrogen ion concentration. So Ka, we will give it as 1.7410 to the negative 5 multiplied by concentration of sodium ethanoic acid 0.186 divided by concentration of ethanoate 0.105. That gives us our hydrogen ion concentration, which we need to use to find pH. 1.74 10 to the negative 5 multiplied by 0.186 divided by 0.105. That gives us hydrogen ion concentration 3.08 times 10 to the negative 5. So I've done a previous video on how to calculate pH from hydrogen ion concentration, but the formula I'll write again, minus log base 10 of the hydrogen ion concentration. So if we put the hydrogen ion concentration into this formula, the pH of the buffer solution is 4.5 to 2 decimal places, 4.51. Second part of the question. So in a different buffer solution, the concentration of ethanoic acid is 0.251 moles per decimeter cubed, and the concentration of sodium ethanoate is 0.14 moles per decimeter cubed. A sample of hydrochloric acid containing 0.015 moles of hydrochloric acid is added to 1000 cubic centimeters of this buffer solution. Calculate the pH of the buffer solution after the hydrochloric acid has been added. Ignore changes to total volume and give the answer to 2 decimal places. Write down our equation. We have A minus plus H plus gives you HA. So this is the acid, this is the ethanoate. In the case of sodium ethanoate, this would be the ethanoate, and this is the protons, which make it acidic. So in the question, we can write this as a table. So we have initial, change, and final. So the concentration of ethanoic acid is 0.251, so 0.251, and the concentration of sodium ethanoate is 0.14. And it says we are adding 0.015 of hydrochloric acid. So it says 0.015 moles, but since we're working in concentrations here, so when we calculate the concentration of hydrochloric acid, concentration equals moles over volume, and so the concentration is 0.015 as well, because we have moles per decimeter cubed, and 1 decimeter cubed is 1,000 centimeters cubed, in cubic centimeters. So if we go back to our table, the change when this reaction occurs is going to be 0.015 because we've added the protons from the hydrochloric acid. So minus 0.015 from this, minus 0.015 from this, and plus 0.015 because it's this forward reaction. So 0.14 minus 0.015 is 0.125. We have 0 for this, and 0.251 plus 0.015 is 0.266. So the concentration of acid is 0.266. The concentration of ethanoate is 0.125. So to calculate the protons, we still need Ka. So Ka we were given on the previous side, but if I recall correctly, I think it's 1.74 times 10 to the negative 5. And from there we can use the equation we used previously, where Ka equals because we've got concentration of the acid, concentration of A minus, and Ka. So we rearrange to find the concentration of hydrogen ions. So we do 1.74 10 to the negative 5 multiplied by the acid, so 0.266, and then divided by this value, which gives us 3.70 times 10 to the negative 5. So now that we've got that value, we can use the value we used, the equation we used on the previous page. pH equals minus log 10 H plus. So pH is 4.43, and pH is always to 2 decimal places. And that's it. That's how you calculate Ka in buffer solutions.